Hello students, welcome to our micro lesson number 2. We're covering order of operations. And I'm sure you're quite familiar with the term PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction. And so today I'm going to be covering two misconceptions, and kind of the second misconception is a strategy to make sure that we don't commit any errors that go against the rules that we understand in regards to priority of what happens. So our traditional understanding when we're first introduced to PEMDAS is that it just goes left to right, parentheses all the way to subtraction. But the reality is that multiplication and division are in the same category, and they can go either division first or multiplication first. And for the second category, addition versus subtraction, those are also interchangeable, and it doesn't really matter which one you do first. But we have to keep something in mind so we don't get tripped up. Number 2 is I want to cover 2 essential skills before we actually get to some of our practice examples. Number 1 is we want to show every step of what we're doing. And essential skill number 2 is we want to understand what a question is asking. And if possible, I'd like students to maybe have a notebook out and write down these 2 essential skills and just take note when, hey, Mr. Yao is doing this example and he's actually showing every single step. Or he's asking himself, what is this question actually asking for us to figure out? All right, I'm going to erase this now. So copy it down, pause it so you can copy it down. And we're going to get started with some examples with order of operations. I'm going to erase this. But keep the PEMDAS up there. So if we have an example problem, say 10 minus 3 times 5, we'll keep it super simple. Our understanding with PEMDAS is that we want to do this multiplication first, and then we do our subtraction second. And there's definitely nothing wrong with that. If we multiply those 2, we end up getting 15. And then, because we're subtracting, we're kind of copying that sign over, and we write all the previous parts that we didn't use, we do 10 minus 15, and we end up with an answer of negative 5. Right? Pretty simple, pretty straightforward. We did those 2 things. But then the next step is, what if we have multiplication and division and we're like, oh man, do I have to do multiplication first? I'm going to show you exactly why we don't. Let's see. 2 times 6 divided by 3. And I'm going to write over here the same thing. 2 times 6 divided by 3. Let's say over here we decide to do this first. Over here we decide to do that first. Okay. 2 times 6, we get 12. And then we just copy down everything that we haven't done yet. Over here, we did 6 divided by 3. We get a 2. And then we just copy down everything that we haven't done yet. So with this expression, we do 12 divided by 3, which we get a 4. And then 2 times 2, we still get a 4. Same answer regardless. And it doesn't matter how many steps you have, as long as you understand that you're doing these operations in this priority, you can switch these. It could be PEMDAS or PEMDSA. So once we practice this a lot, you could just make up some numbers, write out things like, 7 times 2 divided by 2 plus 8 times 16 plus 3 to the power of 4. Doesn't matter. And you could try this out. Maybe try out this problem, see what you get. Compare it to the answer that Mr. Yao doesn't have. But the place where we can get really tripped up is when we have a lot of steps of all within like this range or all within this range. And I'll show one example where we might get really confused. So if we have 10 plus 4 minus 3 plus 6, we could say, well, we understand that all of this is in the AS range, addition and subtraction. So this should be pretty straightforward. I want to do this first and then that first and then do the rest. So let's try that. We have 14 and we have a minus and then 3 plus 6, that's a 9. And then our answer is 5. Boom, we're done. That's the right answer, right? Well, what if we did this? 10 plus 4 minus 3 plus 6. I wanted to actually do this one first because it doesn't matter, right? We have, copy it down, 10 plus, well, 4 minus 3 is a 1 plus a 6. Uh-oh. 10 plus 1 plus 6, that's 17. What's going on here? These two answers don't match. Mr. Yao, you just said these orders don't matter. Well, they don't. But we have to understand what order of operations. Operations, remember we talked about that vocab in the previous lesson? Operations means an action. And these actions are actually attached to numbers. So I'm going to erase the work that I have so far. And I'm going to use a different color to show where these actions actually are. Our actions are actually right here. Plus 4, that's an action. We're adding 4 to something. Minus 3, that's an action. Plus 6. And this 10 doesn't have a sign in front of it, but we know it's positive. So you can think of it essentially as plus 10. These are the actual actions. And let me actually write out the previous version, the one where we got 5. And we're going to compare it to that. And we're going to try to identify what's actually going on and compare the two. So 14 minus 9 equals 5, right? Is this the correct one or is this one? So let's think of these as individual actions. We can go in whatever order we want. Let's say 1, 2, 3, 4. That's the order we want to go in. It's a 2, right? 6 plus 4, we get 10. Number 3, we minus 3. And then number 4, we added 10, right? Well, what do we get? 10 minus 3 is 7 plus 10 equals 17. As long as we keep these signs, which is the action, next to the numbers, we can think of this as a negative 3, or you can think of it as a minus 3. Then we can follow these order of operations, which again means action. Let's actually write that. This means action. Something has to happen. So over here, what is our error? We did this one. This one's okay. 10 plus 4. We did this action. No problem. This is, can think of a positive 10. No problem. What happened over here though? We actually left out the action of what was happening to this 3. And then just moved it there. That's illegal. The action is attached to what? This 3. So it's really negative 3 or minus 3 and a plus 6. So over here, 10 plus 14 is okay. But what about the 6 and this negative 3? Really what this should be, it shouldn't be a minus 9. It should be 6 minus 3 or 3. So we have a 14 and a 3. And because we know this is a positive number, 14 plus 3 equals 17. So the number one rule for understanding order of operations is understanding the definition, what an operation or an expression means. It means an action. And actions have to be attached to things. This minus can't just be moved willy-nilly to in front of this 6. Because what happened before in this incorrect example, I'll write this as wrong. Wrong. Is that we just threw that action wherever we wanted it to be just because we wanted it to. We ignored it and then just placed it right there because it happened to be lined up. No, these actions have to always be attached to something that's happening. And that's a super important concept that needs to be covered and understood by students.